Okay, so you should have log base 2 of x. And here in your calculator, here is mine. This is just on Desmos. Where should I draw the point? Like, where is one that you see that's pretty specific? At 1, 0. So I'm going to put a dot there. At 1, that's a big dot. That's very big. So I'm going to put a dot at 1, 0. And it curves. It kind of looks like the what graph?
I want to say x, but that's not right.
Not x.
Is that 1/2?
It kind of looks like the square root graph a little bit. Do you see an asymptote somewhere? Like, do you see something where it's approaching and getting really, really, really close?
Oh, it's a rotation of the power graph,
The exponent graphs? So it's just rotated. That's a good observation. So we've got a vertical asymptote now at x equals 0. And something that I noticed on your homeworks as I was grading them that I want to mention, because I will count off points, so I need everybody to look at me. If I ask you for a horizontal or a vertical asymptote, if you just put 0, you will get it wrong. It is in this case, it's x equals 0. On the exponential graphs that we learned in 8.1, I think it was 8.1, 8.2a, maybe, I don't know. Whenever we learned the exponential graphs, it was y equals. So make yourself a note right now. If you just put the number for the asymptote, it will be considered wrong, because I don't know what you're talking about. If you put 2, that doesn't tell me anything. I need to know if it's y equals 2, or I need to know if it's x equals 2. So make yourself a note. I'm only going to say it one time, and I'm just going to start counting it wrong. But I noticed it on everybody's homework. So you might want to go back to your homework and fix those so that when you're studying, you can... Yeah, so on the last homework that you did, everything would be y equals. On this homework, it's going to be x equals. Okay? Because it's a logarithmic graph. Now, if I am going to graph log base 3 of x, so go ahead and change that. I'm just adding it. So the red one is log base 2. Second one is the blue one is log base 3. What do you notice about the point? Still the same. And then if I change it to log base 7, what do you notice about the point? The same. What do you notice about the asymptote for all of it? All the same. So they all have a vertical asymptote at x equals 0. And they all have the point 1, 0. What is the only difference that you see? Like, so a log base 2, it kind of has a slope that's more upward. As your base is increasing, it's kind of getting almost more flat, like wider, I guess. I am not going to, so if you have to do these by hand without a calculator, I would never count you off for the slope of sorts, or like the base. So you can make them all look the same in terms of, I'm just going to be grading the direction that it goes in, the asymptote, and the starting point, which is 1, 0. Okay? I just had you graph these with the calculator just to kind of show you what the base does. But I won't grade you on the base. I'm just going to be looking at the asymptote, the starting point, and then once we get to the transformations, I'll be graphing you on those. So let's talk about what are some things that we notice. And do y'all want me, y'all should have drawn the picture, so I'm not going to spend time drawing those. So what do you notice about the graphs? What are some things that they all three had in common? They all pass through. 1, 0. Good. They all have a vertical asymptote.
At x equals 0.
And they all basically have the same shape. The only thing that we notice is that the higher base, like as your base is increasing, it gets flatter. Flat faster. That could be a good way to put it. It just gets more flat. So there are two properties that you will never ever be able to graph or evaluate. In fact, they don't exist. If you type them in your calculator, it'll literally just blow up. The calculator will just implode. So just don't do it. If you take the log or the natural log of 0, it does not exist. So I'm just going to put D and E. Another thing that does not exist is if you take the log of a negative number.
Is that any log or just the log natural?
Any log. So it could be log of 0 too. Or log of negative 2. So any base. I'm going to put an X there. Any base. If it's 0 or if it's a negative, it does not exist. The reason being, and if you want me to kind of show you why, if I were to put this into exponential form, that would look like e to the x power equals 0. Can that ever happen? No. And e to some power equals negative 2. Can that ever happen? No. Like I can't make a positive number become a negative number by just applying a power to it.
Okay, what if it was negative e x to the negative 2?
If it were like a negative out in front,
Yeah.
we don't ever deal with negative logs.
Okay.
Ever. We graph them, but we don't ever deal with negatives. So for purposes of evaluating and even graphing, if you have a 0 or a negative number, we say it does not exist, because it does not exist. So, and also, going back to the last section, if you have a log or a natural log of 1, what does that equal? 0. Good.
So is that basically saying that e to the 0 is equal to 1?
Yeah, e to the 0 equals 1. Anything to the 0 power is 1. So now we're going to try graphing without a calculator. And the same rules are going to apply. Something that I didn't mention that I want to talk about is whenever we learned like what a log is, what did we say that relationship was to an exponential? It's the what?
Inverse.
The inverse. So if you look at the graphs of an inverse or of an exponential, I'm just going to draw it here and here. When I graphed an exponential, what was my starting point?
It was like, wasn't it 0, 1?
0, 1. So it was like right here, and it did this, right? And I had this horizontal asymptote at 0. When I graph a log, my starting point is where? 1, 0. And it looks like this. And I've got a vertical asymptote at 0. Now, I'm just going to put them on the same graph.
It's like they flipped.
When you take the inverse of something, and I think you did this in Algebra 1, but when you take the inverse of any function, you're literally switching x and y. That's what's happening. Or it's reflecting the equation y equals x. So it's literally flipping over this diagonal line. That's what an inverse is it's reflecting that diagonal. So that's what an inverse is, and that's why the exponential graph is like a flipped version of the log graph and vice versa. You don't necessarily need to know that. That's just kind of the why behind it. But you do need to know that for logs, the starting point is 1, 0. The starting point for an exponential is 0, 1.
So what if for our exponential, we had a negative number, so it would be the other way, you know?
Flipped.
How it goes down.
Mm-hmm.
Can you draw that?
Like a negative next to the x or a negative
Well,
in
you know,
front?
If it's like -2 to the x power or something.
That's when it flips the x-axis, so it flips down like that.
Okay, so would the inverse of that, how would that look?
We're about to draw some negative logs, yeah. My suggestion is to not get caught up in that, but to look at each individual function and decide what that transformation is individually. Okay, so let's look at this first one, part A. So I've got log base 3 of x plus 1, and with our transformation rules that are still applying, what would I do if I start at 1, 0, which is right here? What transformation is going to occur?
It's gonna go to the left.
It's going to go left 1. And so I draw like this, left 1. Basic shape is it's up and to the right, and then it's going to go down, and it's going, the asymptote is always like 1 x value away from the starting point.
What's the 3? Do we use a 3 for the log?
No, that's just kind of to show, remember me showing you the 3 different shapes of how flat it got?
Yeah.
This number right here just kind of represents the hump. Like it's not, I'm not going to be grading that.
Okay.
And the asymptote is at x equals what? -1.
Why do we know that?
Because I shifted left 1.
So
So the asymptote is like setting this inside equal to 0, or the transformation that happens. So originally it was at 0. I went left 1, so now it's at -1.
so whenever you move it, the asymptote goes with it.
Like whenever you shift it left or right, that's what's happening to the asymptote. Now let's talk about the domain and the range. Domain, I'm reading from left to right. Where does this function start?
It starts
At -1, and it goes to
at
infinity. Range is from bottom to top.
negative infinity to
So it's going to be all real. Or you could say negative infinity to positive infinity.
so why would it be all real?
Isn't the range always real?
Not always. So I want you to flip back to the last time we graphed exponentials. I think that is in 8.1, I'm pretty sure.
It was one kind of.
And I want you to find where we did domain and range for exponentials. Maybe 8.2.
Yeah.
What was the domain and range for exponentials?
The domain is all real numbers and the range is the actual number.
Okay, so the domain was all real numbers, and the range was your asymptote to positive infinity or negative infinity to your asymptote, whichever way. This is like flipped, right? So I flipped it. So now my domain is my asymptote to positive infinity, and my range is all real. And which makes sense because it's an inverse, so it flips. Which is kind of cool. It is pretty cool.
So we can always just plug in the asymptote for the
Domain.
x value of the domain.
Mm-hmm. All right, what about B? What transformation is happening here? So my starting point's at 1, 0. Right 2. Up 3. I'm going to use a different color.
Yeah, I was right.
And the basic shape stays the same. And so my asymptote is where x equals 2. Not just 2. X equals 2. And my domain and range.
Domain is 2, infinity.
And make sure that you're always doing parentheses. It's never brackets. Because it's an asymptote. So it's approaching it, but it's not actually touching it. And my range is what?
All the numbers.
All real numbers. Good.
Why is it 2?
Because that's where.
Unless it's flipped on the left. Yeah.
Oh, no.
So let's fill in our transformation rules that are like our old trustees. We've been doing them forever. Our old trustees. We added one. We're going to add one. Okay, so if you have the constant on the outside, what does that do? Up or down? If you have it on the inside, it does what? If it's a negative on the outside, what does it do? It flips what? Which axis?
The asymptote for this one.
The x-axis. Always.
Wait, but doesn't it flip the asymptote?
Wait, wouldn't it be
Mm-mm.
one?
It does for exponentials, but for this, it's just the x-axis.
Wow.
So if you have a negative on the outside, the rule is it's always the x-axis.
So how would that
Wait,
fit
but
there?
well, we said that for the exponentials.
Because that
But-
was the x-axis.
Yes. So this one,
It's like just flipping the x-axis. So in this case, if it were like this, it would turn it. So if you had something like that, it would turn, flipping the x-axis in this case would turn it like that.
okay, that makes sense.
And now if you have a negative on the inside, we kind of briefly talked about it last unit, but it would flip the y-axis. And so if I'm gonna start with,
Literally the first one.
so if this is log of x, we could put a base, we could say base 2. This would be negative, well, I don't want to use log, I want to use square root of x, so that one's easier to do. So here's our regular square root of x. If I flip the x-axis, it would be like negative square root of x. And then if I flip the y-axis, it would be like this, where it's now flipping the y-axis, and it's the square root of negative x. It is, but you can still graph it if you put like real numbers in there. If you replaced it with log, so I'm going to show you the log one. So like I said, if you're evaluating them, it does not exist. If you're evaluating the square root of negative 2, it's imaginary. But graphing it, you can actually graph, okay? So the same kind of works with logs. The original log function looks like this. So if this is like log of x. If I flip the x-axis, it just flips like this. Probably should draw that a little better. That's like saying the negative log of x. If I flip the y-axis, use red, it looks like that. That would be log of negative x.
I thought you said we wouldn't deal with the negative log.
You won't evaluate it, but you'll graph it. So you can graph them, you just can't evaluate them. All right, so let's look at some of these. And, we could add a fourth one in there. Negative, negative. What would that look like? Negative log of negative x. Just got them all over the place.
Are we gonna have one of those?
You might.
So we're gonna basically.
You probably could.
There's one
Okay.
right there,
Beautiful.
right under where you wrote it.
Okay, let's do some. So try C.
Okay.
Remember that our rule is we always flip first, and then we go left, right, up, down. So flip first. So I'm gonna start at 1, 0. And the original looks like, so if it helps to like draw kind of a parent function. There it is. If it helps to draw a parent function, then do so. This negative x means that it flips the what? The y-axis. So now it's over here,
What?
like this.
But then it's
That's
up
beautiful. And then it goes up 1.
Oh my gosh.
What's the range for that?
All real.
Do we have, like, we don't have to do, like, what you just did?
No.
What's the positive infinity? Because that just confuses me.
Wait, I don't understand the whole negative.
So I flipped the y-axis. So imagine a pancake. Like right now it's on the right-hand side. Flip it to the left. It's like a reflection.
Okay.
And then I went up 1. So my domain is now negative infinity to 0. My range is still all real numbers. And my range will always stay all real numbers on a log. Just like on an exponential, the domain is always all real.
Can you have a log of an inequality?
Maybe. And then my vertical asymptote is x equals 0.
Oh, I like this.
Okay, I want you to try E and F on your own.
All by myself?
You got it. You got it.
Wait, do we have to?
Wait, what does VA stand for?
Vertical asymptote.
Can I just put acetone?
But it's vertical.
Why is there
See, I know it's vertical.
I have a question.
Yes.
Do you have to put all real numbers, or can you just put like
Negative infinity. Yeah, you can do that. Okay, we got this. So, E. For E, you should have a vertical asymptote at x equals 1 because it goes right 1. And the function should have flipped the x-axis. So where normally it would be going up and to the right, now it's going down and to the right. It was like flipped. On F,
Doesn't it?
it flips the x and the y-axis. So it flips across the y and x. So that's the way it's pointing.
Doesn't E flip the y-axis as well?
No, just the x, because it's a positive x on the inside.
Oh, okay.
I just don't like the when you flip the y-axis. Like I haven't gotten used to those yet.
Yeah, never did tell us the story of the dog.
Oh, yeah.